Okay, so there's a lot of support for time zones in Pandas. So we'll dig into this. So the default library is PyTZ, but there's another library called dateutil, which can also be used if you need to. So by default, if you create a date range, so this is a date range from a certain date and time, it has none type. So if we say this range.tz, this is the time zone, is none. It has no time zone. So to supply the time zone, you can use this tz equals keyword to the date range and other functions. So there's two options. You can either use PyTZ, which is called the Olson TZ database. It's really handy. It has support for all common time zones. And if you're using UTC, there's a special case called TZ UTC. There's also the dateutil module, which also is very powerful, and it uses operating system time zones. So the list of time zones isn't available, but the main ones are available and available to you. So see how this works. We're going to create a date range from this same idea, so from a certain date and time with a period of 10 periods every day, and we're going to set the time zone to London. So now this this range has this attribute, this TZ attribute now has a value. So it's it'll say DST, TZ info, Europe London, LMT -1, etc. So the analogous way you would do this using dateutil would be it's just the same idea, except for we say dateutil / Europe London, and it looks a little differently. This is a local time zone that's stored on my Mac, and to do UTC, there is a special case for that called dateutil.tz.utc, and so this is handy for using UTC. So if we can also generate this time zone explicitly using this PyTZ module, and we can see that it has the same value as this. And we can effectively what we're doing here is we're creating the time zone and then specifying it as an object when we create the the date range. So if we want to take this, if we want to take a Pandas series that we already have created and then convert it into a time zone, we can use this localize function. So all this is going to do is, so you can see here we have these dates. It's frequency D. We're going to maintain that, but when we render it as a time zone, that time zone is this plus part, right? And a UTC is just +0 because there's no time zone, there's no offset. But you'll know that it has a time zone because you'll see that. So we're using this localize function. We've turned that into a UTC time zone. So if we want to convert that to Eastern time, we can just use this TZ convert and convert that to US Eastern. And now you'll see that all the times are now offset by 5 hours. So this is UTC -5. So the times are now, instead of March March 6th at midnight. It's now March 5th at 1900, and then the time zone is -5. So everything's the same, it's just in a different time zone. And so it will understand that these things are the same. So if we have one time in Eastern time and another one in Berlin, the Eastern time will show us that value, and the time zone corresponding to it, and the Berlin timestamp will be in GMT +1, and we'll show that time zone. But if we say, are these two values equivalent, it knows yes, these are equivalent. These are equivalent timestamps. They're just in different time zones. So we can convert this Eastern time to European time by using the TZ convert, and we'll get that time zone switched. And we can take this time that's just like a index or an array. We can do it with a single timestamp. So we can convert this single timestamp to say Shanghai time, which would be GMT plus or UTC +8. And so if we take these two different time zones, Eastern and Berlin, and we try to add those series together, so these series have values, so we're adding the values. So what's going to happen to those timestamps? Well, they'll just get converted to UTC. The indexes match, so it will allow us to add them, but then the time zones will just get converted to a uniform UTC time zone. So the index is now in UTC. If you want to get a list of all the different time zones available, you can type this command here, and it will print all the different time zones in PyTZ, of which there's quite a lot. Including all these sort of GMT plus and minus, which are just kind of handy. So we can either specify the actual city, or if we know the GMT, it's the same. So if we wanted to know what time is it now in the East Coast, so if it's 10:28 here in California, it's 13:28 in the East Coast, it's 18:28 UTC, it's 9:30 p.m. in 9:28 p.m. in Saudi Arabia, and it's using that same time zone. We can get the same value. So, so just to finish here, I want to show you an example of how this all might fit together. So, let's say you want to know what day of the week a certain date will be in a future year, right? Like you want to know, okay, when I turn, when I turn 50 years old, or when I turn 30 years old, like, what day of the week is my birthday going to be on, right? Am I going to be able to have an awesome party, or am I going to have to wait? You could like get the calendar out, but you can do this with pandas. So we can make a function called future day of the week. We're going to pass a date and a year's offset. We're going to end up with a day of the week that's an integer from 0 to 6. It starts on Monday and goes to Sunday. This is how it's stored internally. And we're going to convert that. So first we're going to convert that date to a timestamp. We're going to offset it by the number of years that we provide. So we're going to take that timestamp and offset it by years equals years offset. That's the value we provided to the function. Now it's going to give us that timestamp. And now we are going to print out that we're going to render this format. We didn't cover this function, but this is a way you can render a date using any given string format. So string format time. We get the years offset that we provided. We get the timestamp offset that we generated, and we're going to string format that. And then that offset has a day of the week associated with it. So that's that integer from 0 to 6, and we're going to use our dictionary to generate that date. So, for example, if you were born on the millennium, January 1st, 2000, you would turn 21 years old on January 1st, 2021, and that's a Friday. Or, for example, you want to know how many days from today until a given day. So if that's your 21st birthday, you say your 21st birthday is January 1st, 2021, you can make a period corresponding to that day and subtract from that a period corresponding to today, and it's actually now 10:39. When I did this last night, it was 10:40. Now it's 10:39. So this way you can say, how many days until blank, or how many days until the next presidential inauguration, for example. Count down the days until something more desirable happens, and for example, and so there's a lot of cool stuff you can do. Now, as I said earlier, oftentimes in this data science world, you're going to get you're going to import a data frame that has timestamps already as like one or more columns. And pandas, you can either specify that it's a date-time object, or it will automatically infer that, and so automatically it will store those as a date-time index, and it will give you all this extra functionality of slicing and this really handy sort of smart inference about what you meant. So you can type the date in different formats, and it will still generate that for you. So so that's a lot of information about time series, but should give you everything you need to be able to handle this in your own work.